Alright guys, welcome to another fantastically fun episode of Zyclones, How to Build Your Own Drone. We're at the stage now where we're getting to the fun part where we're going to do the electronics and hooking up the servo functions and everything so it functions precisely, which this is where the complication comes. And as you see, I've got digital radio open up there. And the radio hooked up here, and we'll plug in the helicopter. The radio and the receiver, it's very important when you're using these high power products to use turnigy and stuff like that. I don't generally advise mixing stuff because we'll be dealing lots of amperage being pulled through these thick cables because these are humongous motors. So do not skimp on good quality stuff. And right now we're going to plug in the BEC, get power to our RC systems. Our radio is plugged, and as you see, it shows up on the computer, the screen there, and it also controls the plane. And there's your rudder. I've got the horn off. Anyway, I was wondering why the rudder thing wasn't moving, but we'll get to the little technical details of how to dial in everything here. And basically, I'll show you now. I know there's a little mess off to the side, but don't mind yourself with that. Anyway, on this back, the rudder, you're going to eventually hook this up to the gyro, meaning that this cable here that I have plugged into the radio for the setup purposes, you'll have plugged into this gyro here, and then this gyro into the radio. And this will lock your tail and everything when you're flying. It's a gyro. You can put it in rate or headlock mode, but we're not concerned with that. We're concerned with setting up the rudder first. So I'm going to show you the quickest, simplest way to set up the rudder is have the servo positioned where you want it to be. And remember with these, like you see right there, it is very important. That's the main trick, is get everything at a perfect level thing. The two screws, you just basically put a straight edge across that and use that reference point or a building's reference point, anything level, to level those arms as perfectly as you can get them. But for the rudder here, what you want is zero pitch. Again, please don't mind the mess. So that's like that. When you push back and forth on the linkage, you see the pitch there. And you see about the pitch you'll get there on the back. You want this zero, meaning that this blade here, dead even with the thing. And when you find that, the zero there, which is right there, you want to make this a 90 right there. And that's exactly where you want to place your motor. So let's do that now. This, of course, is not the motor I plan to use on this because a servo motor, because I have another one coming. But temporarily, this will do for the setup purposes. I have the Emaxes that I am going to use, the three up here up top, already in their place. And those are the Emaxes, beautiful things with metal gears. But right now, we'll just pop this servo horn on damn near anywhere, because I'm going to be showing you how to dial this in. But let me get it a bit more level. Come on. Okay. So anyway, now we've got the radio plugged in, all our things on, and I'm going to try to get a little slow shot so one of you guys could actually pause this and stuff, download the video or whatever, pause it. But those are the settings about what you want on your radio to begin with, right? For a 6-channel helicopter, I've dialed those in and everything. But right now the important thing is, you see that swash there? That's to the right. You see how this isn't moving and everything's just shifting around it beautifully. Well, I did move it down there, but you see how it rolls around that, where that stays perfectly stationary. That's dialed in for the left, dialed in for the right. Now you give it forward, and that's what you'll be working on, is for these forward ones precisely in unison. And that back one to rise, where even from the side, when you look at it, it pitches perfectly. Like if there was a little pinhole there, it would pitch perfectly around that center of axis. So we've got forward, we've got back, we've got right, we've got left, then we got all around. And these are fast servos, so you expect them to respond as you do the stick. So that is basically how you want to center that swash plate, where that ball that everything hinges on the middle hardly moves as you give it the all around. You see that? That is a perfect dialing, and you'll be adjusting these once when you put it on. You level it. You get you plug the motor in first. Like say, watch. We'll unplug it. We'll move these servos, whatever. When you plug the motor in, that's first things you do. You won't even put these horns on, because what you do, you pop the horns off. And when you first plug everything in for the first time or whatever, everything will level to the zero. And this is the point where you want to line up that dot and then this screw perfectly level. Just like that. So you plug in your radio, it'll center the servos, then put the thing on here where it's dead 90 degrees, straight up, and this linkage here is the key to the whole setup. It needs to be, according to factory specifications, 1 3/4 of an inch. If you have this precisely measured from the center of this screw to the center of that screw, 1 3/4 of an inch, you level everything around that. So then you'll just basically go around and level the servo from the side, level or the swash plate from the side, and level it from the front. And then you'll work to get that precision like I have here, where that ball stays stationary as you move the thing all around, and there it is on the computer as I'm moving. And those are the settings. You see I have a little bit of trim on 2, a little bit of trim back, negative trim on 6, negative trim on 4, negative trim on 1. But all together, when that comes across, it functions like that. As for the servo, that functions too. But if you listen, do you hear that motor buzzing? That'll eventually burn out. So right there it starts buzzing. You'll want to trim this out, so this tail movement you see right there is smashed against that. 1, you'll want to center that. 2, say right there. 2, you'll want to catch that buzzing and stop it off by doing the travel range on it, which is channel 4. It says right there. I've got it at 40 and 100 now. But the thing is, as soon as you adjust something on a computer here, it'll automatically send it to your radio and make that adjustment there. So on channel 4, you can go to the sub trim here and put in, say, 60s, because I'm so familiar with these perimeters, and I think that right there will start curing the thing. But this is basically the key to centering your aircraft, and everything is 1 on a 450. Have that 1 3/4 of an inch, and then keep everything as straight edged, 90-degree angles, straight edged as possible. If this is off, say when you put it on the gear just by a slight bit, use the sub trim to center it perfectly, because that's what you want. As it throws, it also arcs. So if you put the thing here, you're off on the arc, meaning that if it's coming around this way, it hasn't reached the peak push where it's level, and then it starts going back down. So don't change this, because you're changing the arc of it. It changes the whole throw. Once you fine-tune these things, it should look like this. Basically, as I've been showing you, that ball stays stationary pretty much, and nothing as you go all around. As you go all around, that should stay stationary. And then another thing is, when you give it pitch, this will pitch the blades. You see, there's the blades being pitched. I'm off on a linkage somewhere, because that blade's not pitching. But anyway, as you pitch that, that swash plate should rise perfectly, all servos in unison. And see, it is doing that. So right there we have perfect collective pitch, and this is perfect cyclic pitch. So that's backwards, that's forwards, left, right. and it responds really fast, so there's no issues whatsoever. I hope this has been educational for you, and happy drones.